Come revise GCSE chemistry with me. How did we get from ancient Greece to the modern model of the atom? Hi, my name's Dr. De Bruin. I'm a GCSE and A-level science teacher, and I also make revision videos on YouTube. So in ancient Greece there was a guy called Democritus, and he said that substances could be broken down into smaller and smaller pieces, and then when you couldn't break them down anymore, that was something that he called atomos, which is where the word atom comes from. Now, he wasn't a scientist, but this is where we get that idea from, that the atom is the smallest thing and you can't break it up into anything smaller. Of course, nowadays we know about subatomic particles, but we didn't back then. So the first modern scientist is called John Dalton, and he compared atoms to billiard balls, so like snooker balls. He thought that they were hard, indivisible, not invisible, indivisible spheres. So those little particle diagrams that you first drew in maybe year 7 or year 8 with different coloured circles, that's John Dalton's model of the atom. Now a little bit later comes J.J. Thomson, no P in the name. And he discovered the electron, and he invented the plum pudding model. In the plum pudding model, we have a 3D sphere that's positively charged, and then embedded in that sphere are lots of negative electrons. I don't know about you, I've never eaten a plum pudding, but I have had a Christmas pudding, and it's basically like that, only with plums instead of sultanas. Then comes Ernest Rutherford and his students Geiger and Marston. Yeah, that's Geiger as in Geiger counter. So they did an experiment called the alpha scattering experiment, and this is the one example where you do need to know what they did experimentally to find this out. So they took loads of alpha particles. So an alpha particle is 2 protons, 2 neutrons. It's basically a helium nucleus. And they fired these at an incredibly thin sheet of gold foil. They found that most of those alpha particles went straight through, and that was evidence for the fact that most of the atom was empty space. They also found that a very small number were deflected straight back at them, and so this was evidence for the fact that most of the mass of the atom was concentrated in the centre, in what we now call the nucleus, and also that that nucleus was positively charged, because they already knew that the alpha particle was positively charged. So now we've got the nuclear model of the atom. So we've got some kind of positive nucleus and electrons going around the outside, but that nucleus isn't divided up at all, and the electrons aren't in shells. Then in about 1913, a scientist called Niels Bohr made some predictions about mathematically where the electrons should be. Basically, he came up with the idea for shells, and it turned out that he was right too. Around the end of the First World War, a whole bunch of different groups of scientists were working on similar sort of ideas, and they all discovered at about the same time that the nucleus could be split up into smaller entities that they called protons. They were all doing this at about the same time, so no one scientist gets credit for that bit. And then in 1932, James Chadwick discovered the neutron. And this was really important because it helped us to explain isotopes.